This is my cheap DRO. It has some feeds here from these inexpensive calipers. They've all got a data output, or most of the ones, the cheap ones that I've found. Underneath that cover there's a serial data output. And I feed those into these 6 PCBs, each of which has got a pick on it. And I'll just switch it on. It takes a while to start up because of the TFT display here, which has got a touch screen, and I display menus on there. That takes a while to start up, and then it zeros. So at the moment it's running on my lathe. I've got X, Y and Z there. If I move the carriage of the lathe, you can see that it's updating. The update rate's quite high. It's very usable. It's several readings a second, I'd say. And this is continually reading the 6 channels. So these 6 channels are continually reading. I've got 3 channels on my lathe and 3 channels on my milling machine. And the main processor here, which is an ARM PCB, it's an LPC Espresso from NXP. That displays 3 of the channels, so I can go onto the touch screen and select the milling machine, and now we've got the milling machine. There's a little M down there on this display. The idea with these OLED displays was that I'd change the axis displayed for these 3 LED displays. So now we're on the mill. So we've got Z, and we've got the X-axis and the Y-axis. Over here there's some buttons you can use to zero, rather than having to go through a menu. And then if I want to switch back to the lathe, I can switch back here, and they're at whatever value they were set at before. So things will happen there. So the idea was that this would be a touch screen, and you could do various things here. You could do layouts for circles with drilling holes, or divide between 2 points. But you've also got the option of carrying values from the lathe to the milling machine. So if you were working on a part on one, you could transfer the values over to the other. The main reason for having the 6 channels and not 3 was that I didn't want to duplicate all this twice, because I very rarely work on the lathe and the milling machine at the same time, so I just swap the channels and reuse these displays here depending on which machine I'm working on. These PCBs, I milled those on the CNC 3020 that I've got. The main board is just one single-sided PCB, which has got everything on it. There's some connectors here for these PCBs. Again, these are single-sided. These have got PIC 12F 1822s, I think they are, and they're continually reading the data streams that are coming in on these cables. And the main processor comes down and reads those in an interrupt. So you've essentially got 6 loops going on here, and I did this so that I didn't have to program 6 loops here and read them all in the main processor. I do that down here asynchronously to this one. So effectively you've got 6 independent loops going on in hardware. There's also on here the main circuitry on here, really, apart from the PIC, which is doing the data conversion, is a level shifter, because these calipers run off 1.5 volts. So because they're low power, it's a simple resistive voltage divider. So there's a 1.5 volt supply on each of these boards as well. The whole thing is really quite cheap. I've just priced it up at today's prices, and the main components, the semiconductors, the displays and so on, I think came to about £30 or something. It's very cheap. and the total thing, including the gauges and the main components, was £74. So that's six calipers, 6 channels, the LED displays and so on, and that's excluding connectors and discrete components. So if you double that, you get a figure of about £150 for 6 channels of DRO, which is pretty cheap. I didn't really want to spend too much because the lathe and milling machine didn't actually cost that much. It's ridiculous, some of the prices. These LED displays, I had a look at them, and they're about £1.20, and that includes a driver chip on the back and 8 7-segment displays. It's just ridiculous. These OLED displays are about, I think they were about £4 or £5. So there's quite a lot of cost in those displays, but I just wanted to have access displays that were easy to read and also could change when I moved from the lathe to the milling machine. You could, if you wanted to, just leave those off, and that saves you £15, which is a sizable proportion of the cost of the machine. If you wanted to, you could take this display off. That was quite expensive as well. That was a few pounds. You could take that off and have a button to switch between lathe and milling machine, or you could make one for the lathe and one for the milling machine and not bother with 6 channels on one and just have 3 channels and have 2 of them, and that would cut quite a lot of cost. But eventually I'm going to change the software to give me a lot more options here in terms of calculations and so on. I've also on here, I've built a little programming socket for the picks, so that I don't need a programming adapter. I can just put the pick in there and program it on a standard header. And it's running off a power supply that was salvaged from something, so I didn't actually buy a power supply. It's just running off a 5-volt wall wart thing down there. So yeah, that's my DRO, which I've used quite a lot. The hardest part is mounting these calipers on the machines. So I have got 3D printed brackets at the moment on the lathe, and some of those aren't working too well. On the milling machine I sort of gave up and decided to drill holes in it after working on the lathe, and that is much better. That's pretty reliable and it works pretty well. So I'm going to revisit the brackets on the lathe and actually use something else. Also, the cables I'm using, it's cheap cable with solid core, and occasionally they break off, but I just solder them back on and carry on, so it's not really a problem. It's not a production environment. So I'm quite pleased with that. It's worked well and I use it quite often.